Have you ever pondered the possibility of traveling through time? Could we ever step beyond the present and explore the future or revisit the past? Time travel, a concept that has intrigued the human mind for centuries, is a cornerstone of countless narratives and theories. It's a notion that has transcended the boundaries of age, culture, and era, capturing the imaginations of old and young alike. From the ancient Indian epic of the Mahabharata to the pages of H.G. Wells' The Time Machine, the idea of journeying through the annals of time has been a recurring theme. The allure of time travel is not solely confined to works of fiction. It has also sparked the curiosity of eminent scientists and scholars. Theoretical physicists like Albert Einstein and Stephen Hawking have delved into the intricacies of time and space, their groundbreaking theories adding fuel to the enigma of time travel. Imagine being able to witness the construction of the Great Pyramids, the signing of the Magna Carta, or even the first moon landing. Or perhaps being given a glimpse into the future, seeing how technology evolves or how societies change. The possibilities are endless, the potential for discovery immense, yet the concept of time travel isn't just about historical exploration or future foresight. It's about defying the linear progression of time, challenging the very fabric of our reality. It's about transcending the constraints of the present, the past, and the future, and venturing into uncharted territories of existence. However, as fascinating as it is, time travel remains a complex and controversial topic. It's a concept that intertwines physics, philosophy, and fiction, creating a labyrinth of theories and conjectures. But despite the complexities and controversies, the question of time travel continues to captivate us. We find ourselves drawn to the enigma, captivated by the mystery, and intrigued by the unknown. We yearn for the ability to traverse time, to break free from the shackles of the present, and to venture into the realms of the past and the future. As intriguing as it sounds, the question that hangs in the air is, could time travel ever become a reality? The inception of the time travel theory is deeply rooted in the groundbreaking work of one man, Albert Einstein. Albert Einstein, a name that needs no introduction, revolutionized our understanding of the universe with his theory of relativity. This theory, presented in the early 20th century, introduced a radical concept that time is not absolute, but relative. This means that time can appear to move faster or slower, depending on the observer's speed and gravitational field. The theory of relativity is divided into two parts: special relativity and general relativity. Special relativity, published in 1905, suggests that the laws of physics are the same for all non-accelerating observers, and that the speed of light within a vacuum is the same no matter the speed at which an observer travels. General relativity, published a decade later, added gravity to the equation. It proposed that massive objects cause a distortion in space-time, which we perceive as gravity. The stronger the gravity, the slower time passes. This is known as time dilation. Time dilation is a fascinating concept that arises from Einstein's theory. It suggests that time can slow down or speed up depending on how fast you move relative to something else. For instance, if you were to travel near the speed of light, time would appear to slow down for you compared to someone who is stationary. This means that you could theoretically travel into the future. Einstein's theory of relativity also gave birth to the concept of wormholes, bridges, or shortcuts through space-time. These wormholes, if they exist and could be traversed, could potentially allow for travel to different points in time. It's important to note that while these ideas are intriguing, they remain largely theoretical. The practical implementation of time travel, as we understand it, still eludes us. But it's Einstein's revolutionary theory that set the stage for the scientific exploration of time travel, turning what was once science fiction into a field of serious scientific inquiry. Einstein's revolutionary theory set the stage for the scientific exploration of time travel. As our understanding of the universe evolved, so did our theories about time travel. Let's voyage into the 20th century, a time when our comprehension of the cosmos took a quantum leap. The theory of relativity proposed by Albert Einstein suggested that space and time were interwoven into a single continuum known as a space-time. This was a game-changer. Suddenly, the idea of time travel was not only conceivable, but scientifically plausible. Then came the concept of black holes, celestial bodies with gravitational pulls so strong that nothing, not even light, could escape. According to Einstein's theory, the immense gravitational pull of a black hole could warp space-time, creating a potential pathway to another time or place. Fast forward to the 21st century, where the concept of wormholes has further fueled our fascination with time travel. These hypothetical shortcuts through space-time are still purely theoretical, but their potential implications for time travel are staggering. Among the luminaries who have advanced our understanding of these phenomena are two names that stand out: Stephen Hawking and Kip Thorne. Hawking, with his black hole singularity theorem, deepened our understanding of these mysterious celestial bodies. Thorne, on the other hand, proposed the existence of wormholes and their potential use for time travel, a concept that has captivated the imagination of scientists and science fiction writers alike. Meanwhile, the theory of quantum mechanics, with its mind-bending principles such as superposition and entanglement, suggests that time travel might be possible at the quantum level. Quantum mechanics has also given birth to the many worlds interpretation, a hypothesis that posits the existence of an infinite number of parallel universes where every possible outcome of every event exists. These profound discoveries and theories have pushed the boundaries of our understanding, making the concept of time travel seem less far-fetched. Yes, the idea of hopping into a time machine and journeying into the past or future remains firmly in the realm of science fiction. But as we delve deeper into the mysteries of the universe and the fundamental nature of reality, who knows what possibilities the future might bring? These profound discoveries and theories have pushed the boundaries of our understanding, making the concept of time travel seem less far-fetched. The concept of time travel, while fascinating, is also fraught with paradoxes and problems. One of the most famous paradoxes associated with time travel is the grandfather paradox. Imagine you invent a time machine. You decide to test it by traveling back in time and meeting your grandfather before he had any children. In a twist of fate, you accidentally cause his demise. This leads us to a conundrum. If your grandfather passed away before he had children, one of whom would be your parent, how could you have been born? If you were never born, how could you have traveled back in time to cause your grandfather's demise? This paradox suggests that time travel could result in inconsistencies that defy logic. Another paradox that often comes up when discussing time travel is the bootstrap paradox, which deals with the issue of causality. This paradox is named after the phrase, pulling yourself up by your bootstraps, an action that is physically impossible. Suppose you are a scientist who invents a groundbreaking piece of technology. One day your future self appears and hands you the very blueprints you used to create your invention. You then go on to become the inventor of the device, but here's the catch: who originally designed it? If you received the designs from your future self, and your future self received them from you, then the origin of the designs becomes a closed loop with no discernible beginning. This creates a paradox because it defies the conventional understanding of cause and effect. These paradoxes pose significant challenges to the concept of time travel. They suggest that if time travel were possible, it could result in situations that defy our understanding of causality and the flow of time. These are not just theoretical problems. They could potentially cause real, tangible issues if time travel were ever to become a reality. Yet, despite these challenges, the allure of time travel remains irresistible to many, fueling ongoing research and speculation. These paradoxes highlight the complexities and challenges that we face in making time travel a reality. So what does the future hold for time travel? As we delve into the realm of tomorrow, we find ourselves at the cutting edge of scientific exploration. The current state of research in the field of time travel is a vibrant tapestry woven with threads of quantum physics, general relativity, and the ever-evolving concept of wormholes. These are not just the staple of science fiction, but real, tangible areas of study that could potentially unlock the secrets of time travel. Promising developments are indeed on the horizon. Scientists are exploring the feasibility of creating wormholes, those mysterious tunnels in space-time that could potentially allow for instantaneous travel between 2 points in time. Groundbreaking theories, such as the concept of traversable wormholes, are being meticulously examined. Imagine a future where we could traverse these cosmic shortcuts, making leaps across the cosmos, and indeed through time itself. And yet, with the exhilarating possibilities come profound implications. If time travel were to become a reality, It would radically alter our understanding of reality and our place within it. Our perception of past, present, and future would be forever transformed. History would no longer be a closed book, but a living, mutable entity. The future would no longer be a distant horizon, but a destination that could be reached, explored, and even altered. We must also consider the societal impacts. How would we regulate time travel? What would be the ethical considerations? The potential for misuse is vast, from altering historical events to exploiting future knowledge. These are complex issues that would require careful forethought and robust laws. Yet despite these challenges, the dream of time travel persists. It captivates our collective imagination, enticing us with the promise of exploring unknown territories of time. It invites us to question, to seek, to unravel the mysteries of our universe. While time travel remains a topic of scientific debate, its allure continues to captivate us, inviting us to imagine a world where the boundaries of time can be transcended.